Alright, so we're continuing where we left off, looking at this example. So, medical researchers at hypothetical university, okay, chose 999 subjects to test out a long-term weight loss diet. Long-term means that the participants' weight remains unchanged for 1 year, so they don't gain any weight back. So people are randomly assigned to three groups of equal size. So group A was given the weight loss diet, group B was given a random diet and told it was a weight loss diet, and group C was asked to continue their lives as normal. So the researchers are unaware of who was in what group until after the data was collected. The study spanned 90 days. Now we want to answer these four questions below. So, is this an observational or controlled experiment? So, if we look back, we can see that people were randomly assigned to the three groups. So, since people were randomly assigned, the key word here being assigned, then we know that this was a controlled experiment. The reason is researchers placed participants into groups. So since the researchers placed the participants into groups, it would be a controlled study. Now, if the study was a controlled study, which it was, we want to know if the sample size was large, was it randomized, was it double-blind, and was there placebo? So, first off, was the sample size large enough? So, a good rule of thumb, which we will learn this a little bit more formally and actually put stronger numbers to this, is if you have a sample size that's bigger than 100, then you probably have a large enough sample size. So the answer to the first one is yes, the sample size was large enough. Was it randomized? People were randomly placed into groups, so we will say yes. Was it double blind? So let's reread this carefully. So let's see. Group A was given a weight loss diet. Group B was given a random diet and told it was for weight loss, so they didn't actually know that they were in the random group. Group C was asked to continue their lives as normal, so the researchers were unaware of who was in what group until after the data was collected. So I would say that given I don't have a whole lot of information on what Group A or Group C was told, I would say it's at least singularly blind. I would need more information to know if it was really double blind. And was there placebo? So what a placebo is it's an inactive treatment that people are told is an active treatment. So since group B was given a random diet and told it was for weight loss, but maybe not necessarily was, we would say group B had the placebo. So placebo is when we tell somebody something is an active treatment, but it's not. So it doesn't necessarily have to be a drug, it could be an activity. Was the paper published in a peer-reviewed journal, and what's the journal reputation? We don't know. Now, here's the thing, is we won't talk about how to really get into a journal's reputation, but what does it mean for something to be peer-reviewed? So we toss that word around a lot, and here's what it means. For something to be peer-reviewed, it must be looked at by at least two people who have the same discipline as the study and who are not involved in the study. So you can't just have your study reviewed by your friends because they would obviously be biased. And it also has to be somebody whose profession is in the discipline. So for example, if I was a mathematician and somebody wanted me to review their biology study, that wouldn't work because I don't know enough about it. All right, last question. Did the study follow its subjects for a long enough time? So if we reread this, it says that for long-term weight loss to be long-term, it has to follow them for 1 year. This study only spanned 90 days, so in this context, the answer would be no. It did not, because it did not follow them for the time it dictated at the beginning. Okay, and for the last question, what is the experimental variable and the response variable? So the experimental, that's also called the treatment. Okay, and then the response. So the treatment, or the thing that we are changing or experimenting with, would be people's diet, and the response is weight. So you don't want to put weight loss here, because with the response, we just want to see how their weight changes. Of course, we want to know if it goes up or down, but if we're only looking for weight loss and not weight gain or weight sustaining, staying the same, okay, all those things imply changes, so we want to see how this changes. Now the last question is, I want you to try to remember, how can you tell the difference between a control and an observational study? Well, control is when we put people in groups. So we're controlling what groups they're in. Observational study is where we just ask people questions and they're already in groups. So their behavior has already been dictated before we get involved. All right, the last topic, which is important because it's going to be on your on your knowledge check, is something called confounding variables or confounding factors. So this is a third factor that can explain the difference in outcomes. So for something to be a confounding variable, it has to affect the response and the treatment variable. So here's an example of where we would find a confounding variable. Let's say that people who own horses live longer. All right, so what people might want to say is like, oh, if you own a horse, then you will live longer. But there's something that is actually affecting whether a person owns a horse and whether they live longer that ties these two together. So instead of coming up with a story like, oh, if you own a horse, then you'll automatically live longer because you're happy and things like that, we're trying to find a third variable. So what that third variable would be is money. So you need money in order to own a horse, and you also need money, at least in the United States, to get access to proper health care and maybe proper dietary needs and medication and things like that. So just because you own a horse doesn't necessarily mean you're going to live longer, but both things are connected by the actual key to both of them, which is money. So a couple of other popular examples that I won't write down, but I'll just say out loud, is toy sales seem to increase when the temperature drops. Okay, so when it's colder outside, toy sales increase. So what people might think is, oh, it's cold, kids aren't playing outside as much, so they're going to buy more toys. But the confounding variable would be the holiday season, or Christmas, Hanukkah, Kwanzaa, things like that. So what happens is that these holidays take place around colder climates, at least in the northern hemisphere, and that's also the time when you would purchase toys. Okay, so one is explaining the other one. Another popular one would be that as bikini sales increase, shark attacks increase. So does that mean if you buy a bikini, you're more likely to be attacked by a shark? Well, no. What happens is that bikini sales increase when the weather gets hotter. And also, when the weather gets hotter, people are more likely to swim further out in the ocean, aka more likely to get attacked. Okay? Also, Just saying, I think you're more likely to get attacked if you're wearing a wetsuit than a bikini, but I haven't researched that. Yeah, so things like that where two things might be correlated but don't necessarily cause one another.